Black holes are among the most mysterious and extreme objects in the universe. They are regions of space where gravity becomes so powerful that nothing can escape once it crosses a certain boundary, not even light. For decades, black holes were only theoretical predictions in physics. But today scientists know they are very real, and they exist throughout our universe. But what would actually happen if a human somehow fell into one? Would you instantly disappear? Would you be crushed by gravity the moment you got close? Or would the journey into a black hole be far stranger than anything science fiction has imagined? To understand what happens inside a black hole, we first need to understand how they form. Black holes are created when extremely massive stars reach the end of their life cycle. For millions of years these stars produce enormous energy by fusing atoms in their core. This nuclear fusion pushes outward against the force of gravity, keeping the star stable. But eventually the fuel runs out. When fusion stops, the star can no longer support its own enormous weight. Gravity suddenly takes over, and the star collapses inward extremely rapidly. In only a few seconds the core becomes incredibly dense, compressing huge amounts of mass into a very small region of space. This violent collapse creates one of the most powerful gravitational objects in existence, a black hole. Around every black hole lies a boundary known as the event horizon. This invisible surface marks the point of no return. Outside the event horizon, objects can still escape if they move fast enough. But once something crosses this boundary, escape becomes impossible. Even light, the fastest thing in the universe, cannot travel fast enough to escape the black hole's gravity. That is why black holes appear completely dark. But the most terrifying effects of a black hole begin even before reaching the event horizon. As you move closer to the black hole, gravity becomes stronger and stronger. But this gravity does not pull evenly across your body. The force pulling on your feet would be much stronger than the force pulling on your head. This difference in gravitational strength creates an intense stretching force. Scientists call this strange process spaghettification. Your body would slowly stretch into a long thin shape as gravity pulls you apart. Long before reaching the event horizon, the stretching forces would likely tear you apart completely. But something very strange happens from the perspective of someone watching you from far away. As you approach the black hole, you would appear to slow down. Closer and closer to the event horizon, your motion would appear slower and slower. Eventually, to a distant observer, it would look as if you had almost frozen in time near the edge of the black hole. This happens because black holes do not only bend space, they also bend time itself. According to Einstein's theory of relativity, gravity can slow the passage of time. Near extremely massive objects like black holes, this effect becomes incredibly strong. To someone far away, time near the event horizon appears to move more slowly. Clocks near the black hole would tick slower compared to clocks far away in space. This strange phenomenon is known as gravitational time dilation. Black holes also bend light itself. As light passes near the intense gravity of a black hole, its path curves around the object. This effect can create distorted or multiple images of distant stars and galaxies. Because of this bending of light, a black hole can act like a cosmic lens. This phenomenon is known as gravitational lensing. Deep inside the black hole lies something even more mysterious. At the very center, scientists believe there exists a point called the singularity. At this point matter becomes infinitely dense, and gravity becomes infinitely strong. According to current physics, space and time themselves may collapse into this single point. But exactly what happens there remains unknown. Black holes create another deep mystery in physics. According to modern science, information in the universe cannot simply disappear. But if something falls into a black hole and is destroyed at the singularity, the information about that object should be lost forever. This contradiction is known as the black hole information paradox. Scientists are still working to understand how this paradox can be resolved. Black holes may appear to be cosmic monsters that destroy everything around them. But they may also hold the key to understanding the deepest laws of the universe. By studying black holes, scientists hope to uncover new physics that explains how gravity, space, time, and quantum mechanics all fit together. And in doing so, they may finally reveal some of the greatest secrets of reality itself.